Thanks for your patience. Just had a little bit of technical glitch, and I was waiting for access to enter the class, but Ms. Hanato just ushered me in now, and we are good to go. Thank you. So let's get this thing over with. So we'll go over to, let me just present immediately and we'll continue. Yep. So can we all see my screen? All right, good. All right. Okay, so for today, we'll just continue immediately. We've had taken some time out trying to get in. We have natural language processing part 2. Remember last week we talked about natural language processing. So just like I promised, this week we are going to continue with the remaining part of natural language processing, and our focus will be on how it works. Remember, it's AI-powered chatbot without programming, and so far we have been trying to understand what our chatbots are and how it can be designed and how it can be designed now, because the chatbots that we are relating with in the now are AI powered. And so far, especially in our practical classes, we have been able to see how they work. But so today we want to see how our natural language processing works. And we know that we cannot talk about creating chatbots without bringing this aspect of AI. Just remember at the beginning, we said there are different branches of AI, and natural language processing is a major aspect of artificial intelligence. And so you cannot really talk about chatbots without talking about natural language processing. And so how does it work? How does natural language processing come into play as far as chatbot creation is concerned? And that is what we have been exploring from last week. So today we are going to go into the workings of natural language processing. And here we are focusing on tasks that you can do with natural language processing, the understanding of the language, the generation of the language itself, and the interaction in the language space. We are looking at relationship when we talk about the interaction. How does it relate with the different entities in the language? And here we said it involves using computational techniques. Remember what we said last week when we talked about our computational techniques. We dealt extensively with that, and at least we are balanced with that. So let's just continue. We've spent enough time. Hopefully we'll be able to wrap this up and call it a day. Okay, it is basically the understanding of human language. Now, how do we now use natural language processing to understand human language? If we are able to approach natural language processing in the creation of chatbots, having this at the back of our minds, then we can be confident to create chatbots that will be very beneficial and is fluid. And just like we said the last time, is like humans. But you know that they are not humans. We'll talk about that at the end of the lecture. Okay. Now, when we discuss natural language processing in this light, we are looking at embedding this into our AI. And there are two major types of embedding. We have the knowledge base, and then we have the word base embedding. Okay, let me just, take a bit of time to talk about knowledge base. When we say a knowledge base, what do we mean by a knowledge base? Like every one of us know, we have a kind of repository of entities in a particular place, if I can describe it like that. So we can talk about a database or a data bank, which you are very familiar with. Some of you have worked with databases. You have had to extract information from data banks, and a data store, so some you can refer to it as maybe like a data set. In the light of natural language processing, it is understood to be a knowledge base. It is likened to either a data bank or a database, but it is actually knowledge base. And then how do we embed it? Remember, we are trying to understand how our natural language works. Now, how do we embed this into our natural language processing activity? And then next, we have our word embedding. Now, when we talk of knowledge base, there is the generic type, there is the traditional one, and then there's also the neural knowledge base. When we say neural, I hope you know that we are talking about natural language processing. When you say neural networks and so forth, we're actually referring to deep learning and natural language processing. And what do we mean by neural? We are representing this in vector form. When we say a vector, let's just proceed. When we are discussing vector, what is a vector? A vector is an entity that has, substance and direction. It has substance and it has direction. And we are seeing our knowledge as something that has substance and it has direction, because there is a reason why that knowledge is stored. There's a reason why this knowledge is captured, because we want to use it in natural language processing to process our languages so that we will have this. Just like we explained, we'll be able to understand the language, we'll be able to generate it. When we say generate, I hope you understand from previous classes that we are combining different languages. We generate new ones, or we try to enhance existing ones. And finally, we interact with this language. That is why we are seeing our neural knowledge base embedding as a vector. And when we look at it as a vector, I want us to have an understanding. Some of you that already know when we talk about vectors, a little bit of mathematics here, but that's okay. Just come with me. When we say vector, as it relates to knowledge bases, KBase, just like it is abbreviated there, we have two types. We have our sparse vectors and we have our dense vectors. We are going to be saying that. Remember, we are trying to understand how we can dissect knowledge, how we can use natural language processing in our chatbot creation. Please always have that at the back of your mind. And so, just like I was trying to say, vector can be dense and it can be sparse. But in natural language processing, we are focused on neural knowledge base, and we are looking at dense vectors. dense vectors. And this allows for the capture of complex relationship between entities and their properties. So our vectors are dense. We are not focusing on the sparse one, which is just about zeros and, some more of zeros and ones, which means there is a kind of disparity between the vectors that are communicating with each other. No, that will not be very beneficial to us when we are discussing natural language processing. The dense vector is the to go here. And that's what we're going to be looking at. So don't worry about that. We will try to understand it. I try to bring this out in this particular lecture so that we will have a background, a background understanding of how natural language processing works. Okay? So far, are we good? Are we okay? Are we understanding so far? Please, can I feel you so that I know whether we are together? Are we okay? Can you hear my voice well? Hello? Are we still there? This class is too quiet. Are we understanding so far? Or should I just maybe throw in a discussion forum so that we can just wake up? I hope nobody left because of the wait period. Okay. All right, thank you. So let's continue, just like we were talking about our knowledge base. Let us understand. Let me give you a definition of what our knowledge base is. I wrote here, a knowledge base is a structured repository, just like I explained earlier, of information that stores facts about entities, their attributes, and their relationships. Okay? And I said that these entities are seen, we see them as vectors and not as the sparse type, but as the dense type of vectors. Okay, and then it can be in different formats. It can be graphs, tables, text, just to be able to translate it to a machine understandable format. That's okay for us as far as our understanding of our natural language processing is concerned. Okay, so are we okay with knowledge base? We know what a knowledge base is. Let me take us back a bit. Like I said, we are trying to discuss embedding in natural language processing, knowledge-based embedding and word embedding. When we have an understanding of these two concepts, we'll be able to understand or have a background knowledge and understanding of how natural language processing works. Remember, the topic is about how natural language processing works, computational techniques that help us to understand human language. Okay, so let's go back to knowledge base. Just like I chipped in, we have the traditional knowledge base and then the neural knowledge base. I hope you know that everything is changing. Yeah, we are evolving. Technology is evolving. And then the traditional way of doing things is being enhanced. I would just say it's an enhancement. We are now using AI to make it more dynamic and fluid and more workable, if I can use that word. Now, when we talk about our traditional knowledge base, when the way we used to store data, we just store it in our database. And then it stays there. It's almost like it's scripted. And then you cannot generate, when you talk of generative AI, you are using your architecture, the generative neural network, the different kinds of network, trying to gather different entities and generate new ones. No, we don't do that with our traditional knowledge base. But for the neural knowledge base, which we are focused on in natural language processing, as far as artificial intelligence is concerned, you can do that. And let us go further and see what we are talking about. Just like I said, our focus is going to be on the neural knowledge base. Stay with me, please, and let's proceed. Now look at this. For the traditional knowledge base, how is it represented? Scalability, if we look at it from the perspective of the scalability, the flexibility, and semantic understanding. Now, let's see. The first one, it is challenging to store and query the data efficiently. It has, as you keep putting data, information into the traditional knowledge base, it just increases and is kind of rigid or rigid. Use that. I don't know how you pronounce your own. The traditional methods, they rely on schemas that are fixated. It's difficult to adapt to change or even to new relationships. If there are new relationships, yes, but it's difficult. You have to get your way around it. You have to do a lot of programming, a lot of querying to be able to get out new relationships and information from the database. And then finally here, I said lack of semantic understanding. When we say semantics, I hope we remember that we are talking about meaning. Meaning, sometimes it does not show the meaning the way it should for us to be able to understand it. And that is why the traditional knowledge base is being phased out as far as artificial intelligence is concerned. We are now moving more and more, just like we said, towards our neural knowledge base. We are now focusing and zeroing in on our neural knowledge base. And so let's look at our neural knowledge base. Learning dense vector representation, it helps us to do this. Entities and relationships are represented as dense, just like I told you earlier, as dense vectors in a high dimensional space. There's efficient storage and efficient querying. How many of us remember, I think those of us that have played around with databases, how difficult it can be to query your database? I remember in those days, I used to cram some lines to be able to interact with my database. I even have to, there's this small pamphlet I have. I actually use it religiously to query my database so that I don't miss any dot or any a sentence. I have to learn the query language and so forth. But with a neural knowledge base, you don't have to do that. You don't have to do that. It's easier now. Entities and relationships are represented as dense vectors and high dimensional space, efficient storage, efficient querying. I think I like this one this time around. And then secondly, I said capturing semantic relationship. Now you can capture the meaning in relationships. We're going to be seeing that in a bit. And then when we say context-dependent relationships, we discussed that last week. Please refer to the lecture of last week, and then you will understand when we say we are looking at the context of the language. That was clearly explained. All right. So that's talking about our neural knowledge base. Remember, in discussing the neural knowledge base, we highlighted dense vectors. Let us see our dense vectors. Look at our dense vectors. They are arrays, machine learning arrays, and every single element that you can see here holds significant value. they hold significant value. Now look at this. These are words, and you see how I caught this online, and it depicts how dense the words, the language is. It's not sparsely distributed. The density is captured in this diagram. And what is it exactly? They are different arrays, and each one of them have a significant value. And what are we going to be looking at? Please look at this diagram carefully and see. Look inwards. You will see that they are words. And when we talk about our natural language processing, when you talk about language, can you talk about language without words? And then just see the beauty of the density. And when we see a structure like this, and we are trying to explain the arrays of the elements, we are referring to dense vectors. I'll just give you a little bit of time to just soak this in. And then we'll look at all this. I'm sure some of us are beginning to ask ourselves, what is this? What role? That's what I captured. I captured it as the roles that these different arrays play in natural language processing and how natural language processing works. Okay, so we're going to be seeing the individual roles that it plays, and we'll have a clearer understanding of what we're talking about. Okay, have this at the back of your mind, and those of us that are just joining in, and any one of us, just look at these vectors. Look at how dense as against the sparse vectors that we discussed earlier. I hope you know that when we are looking at dense vectors, we are looking at complex data. So let's just proceed. Are we okay? Right. Now look at the roles. The roles of dense vectors in natural language processing. I'll take our minds back. We are trying to understand how natural language processing works. And then you'll be able to understand how it can help you create chatbots. Some of you have an understanding of that already, especially those of you that participated in the oh, good, thank you. And those of you that participated in the practical classes, please, I hope you did not just stop where we stopped in the practical classes. We encouraged everyone to go further, explore, do more. If at the end of this class you will have a clearer understanding, go back and practice some more, and then you'll be able to create new things. Okay, let us take the first point there. Dense vectors, they turn complex data into rich, detailed format that the AI can easily utilize. You see how dense that is? It can actually turn it into good formats, and then the AI models can begin to use them easily. They throw more light into deep patterns in deep learning, and they can predict. It will help them to predict the next word in a chatbot, especially when we bring in the generative feature into these dense vectors, and they help systems to become smarter and more intuitive. And so you can see promptings from a chatbot telling you, suggesting whether this is the next thing you want, this is the next move you want to make, ask you questions that are related to the questions that you've asked before, and so forth and so forth. This is what dense vector does. This is the role it can play when you are creating your chatbots. And then the next one says dense vectors enable precise measurement of similarities and dissimilarities. Precision. That's the beauty of it. Some of you that have worked with this, you can see how precise it is. They are not humans, remember. And then the last point there, I said facilitate tasks like clustering, classification, regression, and all this it does with accuracy, heightened accuracy. So that's the role that your dense vector plays in natural language processing. Before we get carried away with the wonders of dense vectors, let us just take us back a bit. I said neural knowledge base embedding. Remember, there are two embeddings. There is the knowledge-based embeddings and there is the word-based embeddings. Please don't forget that. And then in describing the neural knowledge-based embeddings, we said entities and relationships are what? They are represented as dense vectors in a high dimensional space. That is why we are trying to see the role that dense vectors can play in natural language processing. Okay, beautiful, understandable. Let's proceed. So, in looking at this, please have at the back of your mind that bring complex data to it. It will help you to analyze it. It will help you in clustering, classification with accuracy, and then it gives precise measurements. Okay, and it, help it when it does all that, there is clarity in the patterns, and then you can decipher or have a knowledge, a clearer understanding of what the patterns, the different patterns in the images are, as far as your natural language processing is concerned. So this basically talks about our, our neural knowledge base embedding. I told you that the second one, the first one is when we talk of knowledge-based embedding, we have word embedding. These two, we have to understand them to be able to understand how our natural language processing works. Next, let us look at our word embedding. For word embedding, it is usually called the continuous word representations. How you represent word continuously, in a dynamic fashion. So the word embedding in natural language processing. All right. Here we said that it involves representing words as dense vectors. You see dense vectors coming into play here in a high dimensional space where semantically similar words are mapped to nearby points. So there's a relationship going on here in understanding. When we talk about semantic, again, we are looking at the meaning. When you know the meaning behind a particular word, there is clarity and there is understanding. But now there is good mapping when you are performing word embedding to have a relationship in the language knowledge base. You now have a good understanding of the relationship. Let's see what we mean by that. I want us to look at this. Please, can we just take some time? And this is where we have our discussion now. Let's have a discussion on this. We explained just a while ago that, what is it? We have a high dimensional space. Just in a nutshell, we're having this diagram of it. And similar words, semantically similar words, please have that in mind, are mapped to nearby points. Now we are seeing different nodes here and different points. Remember, we are talking about a neural network. Now we have one here. Now see, the first one is about male-female relationship going on there. Here we have country and the capital relationship going on in the second diagram. Please, what your take about the relationship that is going on here in this dense vector space? Just tell me what you see. If you are seeing something that is not making any sense at all, still write it down, we'll clarify. But what is your take on the relationship that is going on here? Please, I want to hear from you. Okay, all right. So, all right. Let me give an explanation of what's going on here. Let us take us back just a bit. Semantically similar words are mapped to nearby points or nodes. Now look at the first one. The first one is talking about a male-female relationship. We understand who a man is and is the opposite of a woman, right? And then here, we understand who a woman is and is the opposite of a male. Now look at this. You will see that the blue nodes or the blue points, the blue is on king and the blue is on man. The purple is on woman and the purple is on queen. So which means a man is the one to be a king. A woman cannot be a king. Woman, king, man, woman, queen, man, king. You can see that representation in the formation in that vector space. Now look at the next one. Let's see the next one. Here, I will tell something is going on here in this design. Man, king, okay? Woman, queen. This is how it is trained. This is how the language understands this. In our takeaway at the end of this course, this will come into play again. But if we look at this relationship, male-female relationship, generically and conceptually, this is what we understand it to be. Now, let us look at this country and their capital. And on the other side, you will see that all the brown nodes are actually representing the country, and all the green nodes are representing their capital. And then you can see the relationship between the country and the capital. You can't see the arrow pointing from Canada to Turkey. No, it's pointing from Canada to Ottawa. And then you can see Germany pointing to Berlin. It is giving you an understanding of the semantic relationship in this vector space, in this dense vector space. That's what we are trying to mean. That's what we are trying to pass across when we talk about your dense vector relationship as far as your neural, embedding, your neural knowledge base embedding is concerned. Now we are looking at this word embedding in natural language processing to understand how it works. This is how it works. This is how it extrays it and gives meaning in that vector space. Okay, now let's proceed. Now, what are these features? What are the features we can bring out from here? Let us see the features we can bring out from here. Maybe it will give more clarity as far as this is concerned. Now, look at the features. It says it's capturing semantic information, which we saw just now. The meaning, the context, the relationship of the words that are related in that particular space. Secondly, he said reducing dimensionality. This you cannot do in traditional embedding, traditional knowledge-based embedding that we talked about earlier. But the dimensionality is reduced here because it's making it easier to process and to analyze. You can see the way the arrays are spread out, and then you can easily analyze. Thirdly, here we have that it provides dense representations, okay? Dense vector representations, which can be used to capture subtle semantic differences between words. We saw the differences in the words, the male, the female. We saw the king, the queen. You saw the way the relationship was easy for you to understand at the end of the day. Okay, let's go forward. Let's proceed. Now, how do you now apply this? You have an understanding of this word embedding. You remember we talked about the knowledge-based embedding, and we're talking about word embedding. In case you see word embedding as you go along, and then you begin, instead of word embedding, you see continuous word representation. It's the same thing. Don't get confused about that. They're talking about the same thing. You can say word embedding or continuous word representation, and that's just fine. Okay, so let's proceed. Now, like we said, you have seen the different features. Now, how do we apply it? How do we apply this? First, there we have text classification. You saw clearly how they were classified. They can be used to improve text classification tasks, such as sentiment analysis and topic modeling. If we want to do a topic about, dignitaries, royalty, so we're talking about the king, the queen, and then want to do a topic about country and their capitals, and that's what we are explaining here when we talk about the application of word embeddings. Next, language modeling. Word embeddings can be used to improve language modeling tasks, such as language translation and even the generation of text for our language modeling. Remember, just like I will always take you back to understand that we are trying to understand how natural language processing works. I hope this is throwing light into how it works. Number 3, named entity recognition. I had to bring this diagram, forward so that when I'm explaining this, we have a feel of what it's about. They can be used to improve named entity recognition tasks, such as identifying people, identifying places, and identifying organizations. Next, question answering. They can be used to improve question answering tasks. You can hear task. Is that not what you give your chatbots? Ask it a question, interact with it, send it to do a task for you, and so forth. Okay, question answering, such as identifying relevant documents, answering questions. Now, the beauty of this is this. Later, when we see the applications of our natural language processing, you will see the similarity here. And then you will know that it's because of this particular feature, word embeddings or continuous word representations. That is why the natural language processing can be applied in that sense. So let's just continue. We are now entering proper into the workings of our natural language processing. How does it work? Text input and data collection. Number one work of natural language processing. It gathers text from various sources, such as websites, such as books, such as social media, proprietary databases. It gathers text from all that. It collects them. That's one of the major working of natural language processing. And what it does with that is stores it. Remember, text input and data collection. It stores it in a structured format. Not haphazardly, please. Structured format. That is how it stores it. The next working of natural language processing. We said text preprocessing, if we all remember in our deep learning class. Text preprocessing is coming into play here again. You're preparing the raw data for analysis. And then you remember tokenization, putting it in different tokens, lowercasing, stop word removal. That's removing all those, we've discussed this before. Please go back to your former notes and have a clearer understanding. But that is basically how natural language processing works. These are the things you do. Punctuation removal, stemming and lemmatization. Remember the former classes that we have. And then normalization, correcting spelling errors, expanding extractions, handling special characters. All that comes into text normalization. We are preparing this text as far as natural language processing is concerned. After preparing the text, we represent it. How is it represented? How is it represented? We have here bags of words. What is it? It's a collection of words. We're actually ignoring the grammar and the word order, but keeping track of the word frequency. Remember when we talked about continuous word representation? Continuous word representation, talking about word embedding. Next, text frequency inverse document frequency. Good. Please do your research, read about this. It's a whole new field entirely, but it is relevant and it's one of the ways of text representation in natural language processing. And then it reflects the importance of a word in a document relative to a collection of documents. There's a relationship going on there. And then another representation is word embeddings, just like we have discussed extensively. Next, how natural language processing works. It works with feature extraction. And what do we mean by this? N-grams. N-gram words. N is like a placeholder. It's like a kind of an unknown, so to say, in our understanding of this. It helps to preserve some context and word order, depending on the number of N in the vector space. And then you have syntactic features, parts of speech tags, syntactic dependencies, and then parse trees when you are doing parsing. Remember parsing that we discussed earlier? And then when we say syntax, we are looking at structure. When we say semantics, we are looking at meaning. And now semantic features, leveraging word embeddings and other representations to capture word meaning and context. This is what natural language processing does. Okay? Remember, see here, word embeddings coming into play here again. That is why you now have an understanding of what word embeddings are as far as natural language processing is concerned. Let us look at another major way it works. Model selection and training. You know, we are taking it step by step. We have our pre-processing of our text. We also had our feature extraction. We have our representation of our text. And now we are going straight into model selection and then training. I hope we still remember supervised and unsupervised learning. I hope we still understand. I hope we still remember when we talked about our supervised learning and our unsupervised learning. And then the final point there says pre-trained models. You now have your pre-trained models after you have trained and then you have gone through the supervised learning and the unsupervised learning. For the pre-trained models, we are utilizing pre-trained language models such as DaDaDa and transformer-based models that have been trained on large corpora grammar. But of these models, I hope you still remember GPT. And that's what is the boss now, GPT. But let me digress a bit. How many of us have used the new DeepSeek? DeepSeek. That's a powerful tool. It's quite interesting. Some of you should just go ahead and explore it. And it's actually the in thing now, but no problem. Let's continue. Okay. After you have trained, what do? We deploy. We deploy. And then that's why we're having here our model deployment and inference, natural language processing and how it works. This is another way. This is the next stage of the working of natural language processing. And then we have here text classification. Remember, we classify our text by categorizing them into predefined classes. You understand? Spam detection, sentiment analysis, and so forth and so forth. We classify the different text. And then next, named entity recognition. That's identifying and classifying entities in the text. Next, our machine translation from one language to another, especially, remember the last time we looked at our Google Translate when we were discussing this in depth. And then what do you do next? Question answering. Remember, we are still talking about chatbots. And so when we are relating with our natural language, we are trying to provide answers to questions based on the context that is provided by the text data that we have trained for our natural language processing. Okay? I hope we all follow and we all understand. And when we have done all this, remember, we have deployed. What do we now do? We evaluate. Is what we have taken out, is it okay? Is it doing what we want it to do? And that's where hyperparameter tuning comes in again. Remember our hyperparameter tuning, where we adjust model parameters to improve their performance. We adjust the different model parameters. Go back to our former class and we'll begin to see the different parameters. And finally, error analysis, where we understand the weaknesses in the model and we improve the robustness of the model. Wow, beautiful. And we've done that. We have evaluated and we have optimized. And we go and relax. When we relax, and what do we now do? We begin to iterate, we begin to improve, we begin to modify, and so forth. That's why the last one there says continuous improving the algorithm by incorporating new data. Of course, you begin to have new data, you have refining pre-processing techniques, you're experimenting with different models and optimization features. Optimization is taking place, and different iteration. You're going back, you are going through the whole processing again and again to make sure that it captures every new feature that comes into play as far as your natural language processing is concerned. So that's it. That's how your natural language processing works. Remember, workings of natural language processing. What was the first one we discussed? The text input and data collection. After doing that, you pre-process your text, you represent it, you extract the relevant features, especially syntax and semantics. You select your model and train. You deploy and you evaluate, you optimize, and then you relax and begin to iterate and improve. That is how your natural language processing works. Now, in your creation of your AI-powered chatbot, all this knowledge must come into play. And you will now have a robust chatbot, a chatbot that looks very much like humans. So thank you. I have a giveaway just to like an icing on the cake for this particular module, AI-powered chatbot without programming. But before then, the floor is open for questions. Please, you can ask your questions now. But if we don't have any questions just now, you can always type it later after I give my giveaway. All right? It's just a subtle warning, but please go ahead and ask your questions. Okay, it looks like the lecture was clear enough, and well, here it is. Let me give us a little bit of advice to end the lecture. You know, when you design a chatbot, you okay, you haven't bought. Okay, no problem. When we design a chatbot, this is my giveaway. I'm just trying to, add this. When you design a chatbot, you give it a personality. Somehow you kind of give that chatbot a personality. And usually it's not too different from who you are and what your perception is about who should be answering your questions at the other part of the digital space when you are interacting with your chatbot. And so sometimes you kind of like pretend that your chatbot is human. And in a way, some of us might want to maybe make it feel, make the users feel like you're actually talking to a human being. True of us. Well, yes, you want to make it look like, okay, you're talking to a human being, which is okay. You want it to be as, no, your device should not go off. Just take this. We're trying to see and talk about bias. We're talking about bias, in the creation of chatbots. And so always remember that it is a device. It's not human. It is good for you to make it as professional as possible, as refined as as possible, but you will, at the back of your mind, know that the bot is a bot, is a chatbot, and it's not actually human. So you should be careful about biases. Careful about biases. And in being careful about biases, you don't try to favor some group of people. You don't try to favor the people you feel will be able to understand it. You have to have an open mind when you are creating your chatbot to know that there are different cohorts of people that will be using your chatbot. It should be free of any form of partiality. It should be free from systematic favoritism in the processes and in the collection of your data. Because bias can be understood as a mental and social system where people make decisions based on their intuitions and what they believe. But please have a clear mind as far as the creation of your chatbots are concerned. Do not be influenced by your own bias in thinking that, your perspectives, your needs, your choices are universal. They are not. They are not. Just your own is not enough. Do enough research. Try to see what is happening out there and try to understand the different personalities that might just be using your bot. And if you put that into context and you put that into perspective, you will have a chatbot that is not stereotypical, but beneficial to everybody that should use it. So in a nutshell, what I'm trying to say here is that try as much as possible in the design of your chatbot and even other technologies to look out for biases and don't make bias surface in your creations. With that, I would say we've come to the end of this module, and I hope we have been able to understand how natural language processing works, and we have been able to understand what chatbots are, what AI chatbots are, the differences, and their integration even into your businesses and your endeavors, and how it can be of use to you. And finally, try to mitigate bias as much as possible. Thank you so much. I've just waited a bit for questions, but in the absence of that, I would like to thank this class very much for your understanding, this class have been very patient, for your understanding, for your patience, for following, and for the active participation in most of our classes and even in our practicals. Please don't let it end there. Do more with it and reference us. Tell people about the good work we are doing. And if you have any word of advice, feedback, so we can improve our practice, please do not hesitate to let us know. Thank you so much. You're welcome. Thank you too. Thank you. Amen. Thank you. That's really good for me. Thank you. All right. I wish you all the best, the very best. Bye-bye.